my presentation is on conductivity, and conductivity itself is not a pollutant, but is a measure of a material's ability to conduct an electrical current. When measuring the conductivity of water, you are measuring the amount of dissolved solids in the water. These solids are what carry the electrical charges, since pure water has no conductivity. Streams and rivers usually keep a steady conductivity, so when it changes, it usually means that a pollutant has entered the water. These changes may affect the ecosystem because most organisms can only handle a certain composition of water. Conductivity can be measured by an electrical conductivity meter, which consists of a probe which is placed in the solution and a display. The probe runs a voltage through a solution and measures the drop in voltage. This drop in voltage is converted to microsiemens, which is the usual unit of conductivity. Also, it's the common field practice to measure water samples back at the lab in order to maintain a constant water temperature, since temperature can affect the conductivity of a solution. According to the California State Water Resources Control Board, typical conductivity of drinking water is 30 to 1,500 microsiemens, and freshwater streams have a typical conductivity of 100 to 2,000 microsiemens. This can be affected by whether there's sodium in the water, chlorine in the water, nitrogen, any of those can affect it. It's not conductivity itself that's usually a problem, it's what causes the conductivity that's usually the problem. The only way to lower the conductivity of water would be to purify it and by removing any of the dissolved solids in the water.
Good. All right.
Any questions?
All right, so you said that it's 30 to 1,500 microsiemens is safe drinking water?
Well, not necessarily safe, it just says drinking water.
Okay, and then what was the other number you said?
Probably means safe though.
Yeah, I'm gonna assume that that's
Yeah.
probably like drinking water must be considered safe if it's considered drinking water, kind of a thing.
Yeah.
Right.
Then freshwater streams have a typical conductivity of 100 to 2,000 microsiemens. But this is
Say those numbers again. I'm sorry.
100 to 2,000 microsiemens.
Microsiemens?
Yes.
I've never heard of that unit.
Well, this is let's say if you're going to use like a probe, this is what the display would show you. It's microsiemens. It's what's usually, I guess, measured for conductivity when you're, let's say, doing this testing water that you would find in a lake or stream.
Oh, okay. What's the like meters would be M? What's the unit abbreviation for Siemens?
I want to say it is just like micro S divided by, I guess, centimeters cubed.
Okay. So big S, little s, do you know?
Don't quote me on it.
Okay.
Yeah, and it can be affected. This is from the California State Water Resources Control Board, so it could be different for Michigan. I mean, probably if you're closer to an ocean, you might have higher conductivity, there'd be more salt, anything like that can change it. Whether there's a lot of erosion, like different materials in the water, it can all change.
Rivers would probably have a higher conductivity than lakes, because with the lakes everything can sink and just stay there, but with rivers everything's always getting pushed through.
Yeah, the erosion and all that kind of stuff.
Any other questions, guys? Very good. Thanks, Hannah.